Hey everyone, it's John, and today we're going to continue back on the key concepts video series where I take some IP routing key concepts and break them down to give you a broad overview to help supplement your textbooks. So okay, in this video we're going to be continuing on OSPF stub areas, but this time we're going to be looking at the totally stubby area. So with that said, let's kick on, let's do it. So as per usual, let's go to the trusty whiteboard then, shall we? Okay, now in the previous video we just discussed stub routing, and what happened was we had some external routes from EIGRP autonomous system number 51 being redistributed by the ASBR into the OSPF domain. They were then propagated throughout the OSPF domain into the areas, but we had decided to make area 88 a stub area, which meant that the ABRs would filter and effectively terminate the type 4 and 5 LSAs before they penetrated into area 88, okay? So instead, what happened was area 88 for external routes was given a default route to each of its ABRs. Now crucially, this cut down on overhead because it meant that we didn't need to keep track of all these E2 routes, but also we still kept our inter-area routes. That meant that if we had a look back on router 7, we still had the routing information from the type 3 summary LSAs to know to route out of this interface and through this ABR and not this one nor this one. Similarly, if we had to ping the look back on this, because we still had the summary LSAs, we knew intelligently to route through this ABR and not this one because that was the most efficient path. Now that was because we had multiple ABRs. Let's look at area 10 just now, okay, this one over here. This one only has one exit point out, so maybe we could do something more efficient, and that's what we're going to talk about in this video, so let's just discuss it then, okay? So to actually highlight this, what I've done is not just add in a large volume of E2 routes, I've actually added on quite a lot of loopbacks on router 7, from area 77, router 8 from area 88, and router 9 from area 99. That means that we're going to have a high volume of type 3 summary LSAs. Now, like I say, in area 10, we're going to actually make this a totally stubby area, and the way you do that is simply configure the router within the area as a stub, just set the stub flag, but the ABR actually say area 10 stub no summary. That means to make it a stub, i.e. cut out type 4s and 5s, but also no summary, so no summary LSAs, so that means no type 3s. In effect, that means that, let's just pretend we had a lot of routers within area 10. For all the routes on these routers, we would still see them just fine. They would be intra area OSPF, so they would still show up, but anything outside our area, we just get this default route to say, listen, put it to the ABR, and the ABR will still have the path to get to it. So that's what we're going to do here. So what I'm going to do is look at the configurations first, and you'll see the high volume of type 3 LSAs as the IA routes as well as the external routes, because we've got no stub configuration yet. We'll first put a stub on, and then after that we'll make it even more efficient by making it totally stubby, and you'll see the difference. Okay, so let's go and do that now. Just close this, pull this down here, okie doke. Now let's look at the routing table for router 10, okay? So if we do a show IP route, now remember we've not got any stub configuration at all on just yet, so we still see all the E2 routes as well as all the type 3 inter-area routes, okay? So this is a very, very large routing table, and let's just imagine that this is a small branch kind of site, and we don't want to have to host all these routes, okay? It's just pretty inefficient, especially when any traffic that is not within our area is just going to go through this router anyway. So first what we'll do is we'll first configure it as a generic stub, and we'll remove all those E2 routes, okay? So all we need to do is just set the stub flag and just do area 10 stub. Okay, that's all fine. And router OSPF1 area 10 stub. So now we should have our adjacency re-established. We do our show IP routes. We've now removed all the external E2 routes, but we've still got all of these inter-area type 3s, okay? So if we've got a lot of them, we want to cut them down as well. So the way to do that is only on the ABR you need to type this command. All the others within the area just keep a simple stub configuration, but on the ABR we're going to say we want to have, just type out there, area 10. We want to make it a stub, so that removes type 4 and 5, but we don't want summary LSAs either, okay? So that removes the type 3s. So now we're saying area 10 stub no summary, which is going to remove type 3, 4 and 5, i.e. the E2 routes as well as all the inter-area routes. So if we do that, we'll should now see a change. And if we go here over to router 10 and we just clear our routing table, speed things up and show IP routes. Now we see that that's our entire routing table now. All our external routes will just be going through Ethernet 00, and if we let's just check connectivity, let's just grab a random loop back on here. So just grab one of these ones, copy you, let's go to router 10, see if we can ping it. And we can still ping it completely fine, okay? Because what's going to happen is we're just going to default it, send it to the ABR, and the ABR still has the full routing table, okay? So it can still route to it all. So effectively, we're just truncating that routing table completely by removing anything that is not an intra OSPF route. That would mean that if I just go back to my little drawing board, and let's just say that, imagine that we actually had lots of routers within our area, okay? All of these routes would still show up because they would be intra-area, they would still be within our area, we'd still see them and learn them dynamically as OSPF, but it just means that anything out with this area, just send it to the ABR, it will sort it out. We don't need to internally know these within our routers within the area, okay? Only the ABR needs to know them, and it's going to cut down on the overhead. Now, one of the things I would wonder about is that when you configure these, why even make this OSPF? Could you not just make this just a static route and just default static route everywhere? But remember, by keeping this OSPF and as a totally stubby area, it means that routes advertised within area 10 still get advertised to all the other areas, okay? So we still have that kind of dynamic learning in place. So let me just demonstrate that. If I go here and just put on what we'll do, a interface loopback 1.IP address, I don't know, 13, 14, 15, 16. Okay, and IP OSPF1 and advertise into OSPF. It means that if we go to say router 7 and did a show IP routes include 13, 14, 15, 16, it's going to show up. We're still going to get that dynamic learning, so it's not just a simple static default route out. We still have full OSPF running through. It just means that we're effectively filtering what we see in our local table, but we can still advertise routes right through. So again, I get the best of both worlds there. I'll just show you it's still here as well on this router. Include 13, 14, 15, 16, and we still learn it here, okay? So we still have that kind of full dynamic learning throughout the OSPF domain, okay? And the last thing I want to point out is that because the totally stubby area is only configured on the ABR, you can actually have a blend of them both, okay? Now let me just show you this. This topology doesn't really lend itself to this kind of design, of course, but let's just demonstrate it just to see the configuration. So if we went into, let's say, in fact we'll make router 8 a stub first. Okay, so router OSPF1, area, I think that's 88, isn't it? Area 88, and set the stub flag. Now what we'll do is we'll actually make this one totally stubby, so conft router OSPF1 area 88, and we'll do a stub no summary, and same again on router 6. Fucking type router OSPF1 area 88 stub no summary, okay? And we also just went into router 2, but we just made this one a generic stub. So we're not going to make this totally stubby here. So router OSPF1, and we're going to do area 88 and just do stub. I really should change this duplex mismatch, but you get the drift. Okay, so what this actually means is that effectively we're going to have 3 ABRs, but now we've got a preferable ABR for everything. We're always going to be routing through router 2, and effectively routers 9 and 5 are just going to be backups in case router 2 fails, because any routes learned, for example the 13, 14, 15, 16 one we learned here, that will be advertised with specificity with router 2. So if we go in through here and we did show IP routes, okay, and do our include 13, 14, 15, 16, it's going to be advertised out of Ethernet 00, okay, because it's going to go through here, because this one actually is advertising that inter-area OSPF. These ones are just filtering, they're just giving you a default route. So effectively, all of our inter-area OSPF is just going to be going through there because that's always going to be the longest match. So it's always going to go through the center router. But like I say, if that router fails, in IPvZero, just shut the link down. Okay. And we did our show IP route. Give us a wee second. There we go. So everything else is just going to go through these other two backups as the default. So effectively we can actually blend them both together and say we want a preferable router. We'll make that a stub and make the backups totally stubby, and then the stub will be the preferred router. So we can do them both because the totally stubby configuration are only done on the ABRs, okay, with the no summary command. So that's pretty much the end of this video. The next one's going to be on not so stubby areas. It's going to get more ridiculous, and I'll do that one tomorrow. Okay, dope. So thanks very much. I'll see you guys soon.